Welcome to Mindcast, the podcast where we dive deep into the fascinating intersection of cognitive science, technology, and human potential. I'm Will, and today we're exploring something absolutely revolutionary that's happening right now in the world of knowledge discovery. We're talking about what I call the smart librarian and the human scholar, a new symbiosis that's fundamentally changing how we think, learn, and make breakthroughs. You've probably heard about AI and large language models lately. Maybe you've used ChatGPT or Claude to help with some task. But here's what most people don't realize. We're not just dealing with fancy chatbots. We're witnessing the emergence of two profoundly different types of intelligence that, when combined, create something far more powerful than either could achieve alone. Think about it this way. Humanity has always had tools to extend our capabilities. We invented the wheel to move faster, telescopes to see farther, and computers to calculate beyond our limits. But large language models, they're cognitive partners that think in ways that are fundamentally alien to how our minds work. And that's exactly what makes this partnership so exciting. Today, we're going to unpack this revolutionary collaboration. We'll explore how your brain processes information versus how an AI processes it, dive into real-world case studies where this partnership is already accelerating scientific discovery, and tackle the challenges and risks. So grab your coffee, settle in, and let's explore this new frontier of human-AI collaboration. Let's start with something that might surprise you. Your brain and a large language model don't just think differently. They operate on completely different architectural principles. It's not like comparing a Honda to a Tesla. It's like comparing a bicycle to a spaceship. Your human brain is what we call a time-bound serial processor. Imagine you're trying to solve a complex problem. Your brain handles it step by step, in sequence, one thought following another through time. You hold maybe 4 or 5 concepts in your working memory at once. That's it. That's your cognitive bottleneck. This limitation actually defines how you think. Because you can only juggle a few ideas at once, you're forced to be reductive. You simplify complex problems down to manageable chunks. Even doctors in emergency rooms, when making life or death decisions, typically base their choices on just 1 to 3 key variables. Your brain also locks you into strict temporal flow. You experience what's called the attentional blink. If you successfully identify one thing, there's a brief window where you're essentially blind to the next stimulus. Your awareness moves through time in discrete snapshots. Now contrast this with how a large language model operates. These systems are built on the transformer architecture, and the key innovation was replacing sequential processing with massive parallelism. An LLM can process hundreds of thousands of words simultaneously, not one after another, all at once, in parallel. The real magic happens in how they represent knowledge. Instead of thinking in words and concepts like you do, LLMs create what we call vector embeddings. Essentially, they convert every piece of information into coordinates in a vast, high-dimensional space. Imagine a map, but instead of just north, south, east, and west, this map has thousands of dimensions. In this space, the geometry is the meaning.
Words and concepts that are related cluster near each other. King sits close to queen, walking near running. But here's where it gets wild. The LLM can perform mathematical operations on these relationships. The famous example is king minus man plus woman equals queen. It's literally doing math on meaning. Now, here's something that blew my mind when I first learned about it. LLMs are incredibly good at navigating abstract conceptual relationships, but they're surprisingly bad at basic physical spatial reasoning. Show an LLM an image and ask it which object is to the left or right of another, and it often gets confused. This isn't a bug. It's a fundamental feature of how these systems work. You see, your intelligence is grounded in embodied experience. You grew up in a physical world, learning about space by crawling, walking, reaching for things. From that embodied foundation, you built up to abstract thinking. But LLM intelligence is grounded in the statistical landscape of language. It learned about relationships not by moving through the world, but by analyzing patterns in text. It developed an incredibly sophisticated understanding of conceptual space. but that space isn't tied to physical reality in the same way yours is. This creates a perfect complementarity. You excel at causal reasoning, common sense, creativity, and ethical judgment. The LLM excels at breadth-first searches through vast knowledge spaces, pattern recognition at massive scale, and making connections across disciplines that no human could ever perceive. When you're researching a topic, you're limited by your memory, your reading speed, your ability to hold multiple concepts in mind simultaneously.
But imagine having a research partner that has instantaneous access to essentially the sum of human written knowledge, can process it all in parallel, and can identify subtle patterns and connections across the entire corpus. And this brings us to our central metaphor, the smart librarian. Because to understand what's really happening here, we need to think about the evolution of information management throughout human history. Let me take you on a brief journey through the evolution of the librarian, because this story illuminates exactly what's happening with AI right now. In the ancient world, think the Great Library of Alexandria, information was scarce and precious. Librarians were guardians, protecting knowledge from the ravages of time. Then came the printing press in the 15th century, and suddenly we had an information explosion. The librarian's role evolved. Now they needed to organize abundance, not just preserve scarcity. This is when we got systematic classification systems like the Dewey Decimal System. Fast forward to the computer age, and librarians became information specialists, helping people navigate digital databases. Then, the internet arrived, and the challenge shifted. Now it wasn't about access to information, but information overload. The modern librarian became a digital curator, helping people distinguish reliable information from misinformation. Here's the pattern. Each evolution was a direct response to a fundamental shift in the information landscape. Scarcity demanded custodians. The printing press created a volume crisis that required organizational experts. The internet created an abundance crisis that required digital literacy guides. And today we're facing a new crisis, one of information complexity and hyper-specialization. The sheer volume of knowledge, siloed into thousands of subdisciplines, has exceeded human capacity for cross-disciplinary synthesis. Enter the large language model, the ultimate smart librarian. It has access to the most comprehensive repository of human knowledge ever assembled. It can perform instantaneous retrieval and synthesis across vast corpuses of information. But most importantly, it can identify novel connections between disparate fields that no human could ever perceive. Because all knowledge in its training data exists in a single continuous semantic space, it can engage in what I call serendipity engineering, systematically uncovering the types of unexpected cross-disciplinary connections that have historically driven scientific breakthroughs but were largely left to chance. Now let's get into the really exciting stuff, how this partnership is already transforming scientific discovery. First, systematic literature reviews. If you've ever done academic research, you know how tedious these are. Researchers have to manually screen thousands of papers, extracting key information, synthesizing findings. Recent studies show that state-of-the-art language models can reproduce quotes from academic papers with over 95% accuracy and answer specific research questions with about 83% accuracy. But here's the kicker. Using LLMs for initial screening can reduce a human reviewer's workload by 33% to 93%. In materials science, researchers used an LLM to analyze thousands of research papers and extract descriptive labels for micrographs. This created a large, novel, structured data set that would have been prohibitively expensive for humans to assemble manually. And then there's my favorite example, drug discovery. Researchers prompted GPT-4 to hypothesize novel combinations of non-cancer drugs that could be repurposed to treat breast cancer. The model generated plausible hypotheses based on its knowledge of biochemical pathways. But here's the remarkable part.
Subsequent laboratory experiments validated several of these AI-generated combinations. The LLM identified subtle statistical co-occurrences in vast medical literature, perhaps shared biochemical pathways between drugs from completely different domains.
A human researcher might never make such a leap, but for the LLM, all knowledge resides in one continuous semantic space. This is what I mean by serendipity engineering. Instead of waiting for accidental breakthroughs, we can now systematically explore the space of unexpected connections. We're seeing the emergence of what researchers call hybrid intelligence, and it's more sophisticated than you might think. Scientists have identified 3 levels of LLM integration and research. Level 1 is LLMS tool, basic automation like text summarization. Level 2 is LLM as analyst, more complex data processing with less human intervention. And level 3 is LLM as scientist, where it operates as an active agent, formulating hypotheses and proposing experiments. The real magic happens when you combine these capabilities with human intelligence. The LLM-4SD tool, large language model for scientific discovery, synthesizes knowledge from literature and infers rules from experimental data, then uses these insights to augment traditional machine learning models. This hybrid approach has boosted prediction accuracy by up to 48% in tasks like predicting quantum properties of molecules. Some researchers argue we're witnessing the emergence of a 4th paradigm of science. We've had experimental science, theoretical science, computational science, and now AI-driven science, where artificial intelligence isn't just a tool, but a genuine thinking partner that can generate novel, testable hypotheses from complex, cross-disciplinary data. This is fundamentally altering how knowledge gets created. The LLM operates by identifying statistical correlations and semantic proximities within its knowledge space. It doesn't reason the way you do through logical deduction. For an LLM, a hypothesis is essentially a high-probability textual completion that bridges concepts which might seem unrelated to human experts. But here's what's absolutely crucial. This isn't about replacing human intelligence.
It's about amplification. The most effective applications augment human scientists rather than replace them. The synergy comes from complementary strengths. The LLM excels at breadth-first search, rapidly scanning its entire knowledge base for patterns. Human scientists excel at depth-first causal reasoning, critical evaluation, experimental design, and ethical judgment. The future belongs to researchers who can effectively collaborate with these AI systems, leveraging their unique capabilities while maintaining human oversight and creativity. Now, before we get too carried away with the excitement, we need to talk about the challenges and risks. This smart librarian metaphor isn't perfect. There's some serious perils in this new library we're navigating. First up, hallucination. In the AI world, this refers to when language models generate plausible-sounding but completely incorrect information. They'll confidently cite non-existent research papers or present fictional facts as truth. This isn't a bug that can be easily fixed. LLMs are trained to predict the next most likely word. They're optimized for fluency and confidence, not accuracy. This creates a systemic incentive for models to invent answers rather than acknowledge uncertainty. Then there's the bias problem. These systems are trained on internet text riddled with societal biases about gender, race, culture, and ability. The models inevitably learn and reproduce these harmful stereotypes, posing a grave threat to the objectivity required for scientific research. A survey by the journal Nature revealed deep unease among scientists about content responsibility and the need for complete transparency when AI tools are used in research.
There's growing consensus that human oversight is absolutely essential. But here's a more subtle risk: cognitive atrophy. Recent research has identified a negative correlation between frequent AI tool usage and critical thinking skills. When we delegate mental tasks like summarizing and analyzing to external systems, we exercise our own cognitive muscles less frequently. If the smart librarian does too much of the foundational work of reading, synthesizing, and writing, could our own capacity for these tasks diminish over time? We've seen similar patterns with GPS navigation,
reducing our spatial memory abilities. This necessitates a fundamental shift in how we think about education. As AI handles routine information processing, we need to focus on higher-order cognitive skills, sophisticated prompt engineering, critical evaluation of AI-generated content, and ethical reasoning about human-machine partnerships. The key insight is that we need managed epistemology. For tasks requiring factual accuracy, we must maximize faithfulness and implement rigorous verification protocols. But for tasks demanding creativity and discovery, we can strategically leverage the model's probabilistic leaps, provided we treat outputs as starting points for human validation, not as established facts. So, where does this all lead us? I think we're looking at a fundamental partnership of architectures. The evidence points to a clear conclusion. The future of knowledge work lies in symbiotic collaboration between human minds and large language models. These aren't competing intelligences. They're profoundly complementary. Your human mind excels at deep causal reasoning, creativity, and ethical judgment. The LLM excels at breadth, pattern recognition, and synthesis at a scale beyond human capacity. The smart librarian metaphor holds true. The LLM doesn't replace the human scholar, it empowers them.
By handling the immense cognitive burden of surveying, organizing, and connecting vast repositories of knowledge, it liberates human researchers to operate at their highest level. It allows scientists to focus on the tasks humans still do best, asking insightful questions, designing elegant experiments, interpreting results with wisdom, and steering discovery with moral judgment. But success in this new era requires more than just access to the technology. We need to cultivate AI literacy, understanding the strengths and weaknesses of our new cognitive partners, developing critical faculties to evaluate their outputs, and fostering ethical frameworks to guide their responsible use. This means learning when to trust our AI librarian as an oracle of established fact and when to engage with it as a creative muse for a speculation. It means developing the metacognitive skills to know when we're looking for verification versus when we're seeking inspiration. The greatest scientific breakthroughs of the coming decades will emerge from this collaborative dynamic, where human intelligence and artificial intelligence each contribute what they do best. We're not just observers of this transformation, we're active participants in defining how this partnership evolves. We have the chance to shape a future where these cognitive tools amplify the best of human intelligence while helping us transcend the limitations that have historically constrained discovery. The library of the future isn't just a repository of information, it's a dynamic partnership between human curiosity and artificial intelligence, working together to unlock insights that neither could achieve alone. That's our exploration of the smart librarian and the human scholar for today. I hope this has given you a new lens through which to view the AI revolution unfolding around us. Until next time on Mindcast, keep questioning, keep learning, and keep pushing the boundaries of what's possible.